this integral looks kind of fun. The reason is because if we just let this equal to t, right, represent x in terms of t, that's not going to work. Because in the end, it's still going to be a root, right? Not polynomial or rational function, so not good. So instead, here we do this. Instead, we let the whole integrand equal to t. So the integrand, let's call it, okay, let's copy it down. 1 plus q 1 minus square 1 minus integrand equal to t. So here is a technique. We cubic both sides. So t cube equals this cube plus this cube first. So we have this plus this. So the plus square root minus square root, they cancel out. 1 plus 1 equal to 2. So I have 2 first, begin with. Now, I plus 3 times this square times this. Right? So, this square. But this square, I can put the square inside the cubic root. Right, this is perfectly fine. And times this. Since times this is a cubic root, here is a cubic root. I just combine the cubic roots. Right? So copy down the inside. 1 minus. Okay. So likewise, I just plus 3 times same strategy, right? So this times this square. Likewise, they both have cubic roots. So altogether cubic roots, except this times this square. So 1 plus times this square. That's the difference. The square goes into this guy. Here the square goes into this guy. So, but here we notice that. So here we notice that this square, I distribute one of these onto this. So immediately I have difference of perfect square. Right? Likewise, distribute one of these onto this, so difference of perfect square. So difference of perfect square becomes this 1 square minus this square. So 1 minus 1, minus minus, so x cubed. Right? X cubed. So multiply by 1 plus. Plus 3 cubic root. Here, distribute one of these onto this, so difference of perfect square. So 1 square minus this square. So 1 minus 1 and minus minus, so plus x cubed. And I only have one of these left. 1 minus. Okay. So since here x cubed and cubic root becomes x, so this can be taken out. Just 3 times x times cubic root of. Likewise, this x cubed and the cubic root I just taken out, become 3 times x times cubic root. So I immediately factor out 3x. I'm left with cubic root 1 plus cubic root 1 minus Right? But this is exactly t. Again, right? So 2 plus 3x times t. Right? So like I said, I cube both sides, right? So t cubed becomes this. So in fact, I have this relation. Right? I can even express x in terms of t. I just simply t cubed minus 2 over 3t. Right? Now I can make a substitution of variable. Because I can easily work out dx is what? Okay, so here. So this is equal to over t squared over 3 minus 2 over 3t, right? So immediately dx is what? T is 2 over minus plus, right? T to the negative 1, right? 2 over 3, t to the negative t squared at the bottom, together dt. Now, since we've achieved the dx, now the only job is to change the boundaries, right? So when x is equal to negative third, what does t equal to? Right? If we just straight away plug into here and here, it's hard for us to calculate. Right? So instead we, like I said, after I cube both sides, I get this expression, right? We start from here, right? That's a good idea. So if I plug x equal to negative 3 in here, so what do I have? So immediately I have 2 plus 3 times negative, so negative 3 times negative 1/3, so minus t cubed. So t cubed plus t minus 2 equals 0, right? So if t is equal to 1, right, 1 plus 1 minus 2, yes, 1 is the solution, right? T equals 1. Right. Now, which means t minus 1 is a factor, right? We can use long division, right? Divide this into this polynomial and come up with a quadratic expression and factor out that quadratic polynomial. I'm not going to get into the details, but after we get the polynomial, right, the quadratic only has complex solutions. This is the only real solution, right? And we're going to rule out the complex solutions, get rid of them. The reason is because here we start from here, right? So t is like a linear. After we plug negative 1/3 into here and there, so here we have a linear equation in terms of t, right? But somehow after I cube both sides, I get a cubic equation, okay? So that's the reason we have extraneous solutions, right? Extraneous meaning extra solutions. Extra solutions that don't satisfy the original equation. Only this satisfies. The other two complex solutions are extraneous. So, in fact, it can be proven that x equal to negative 1/3. This can equal to 1, right? But straight away, it's very difficult to calculate. But at least we know that this will turn out to be a real number, right? This will turn out to be a real number as well. Right? So I can already change the lower bound into to 1. Upper bound. Upper bound is when x equal to 1. So we plug into here. So 1 minus 1, 0. 1 cubic root 1. So 1 goes into here. 0, 1 minus 1. 1 over 0. See, 1. 0, 1, cube, 1. Yeah, 1 plus 1, 2. So upper bound is 2. Right? And again, because like I said, we have extraneous solutions, right? After we cube both sides, right? Cubic equation. And if you, like I said, if you plug x equal 1 into here, right? We somehow get 2 plus 3t. Right? So the t cubed minus 3t minus 2 equal to 2. I can easily check that. Okay, if t equal -1, so -1 minus 2, -3, and negative plus 3, so 0. Fine. So this is a solution, right? Which means t plus 1 is a factor. Again, we use long division. Right? We come up with some quadratic polynomial, right? And factor that out. Right? I'm going to skip the details of the long division. And so this is the polynomial quadratic. So I believe it's t squared minus t minus 2, if I'm correct. Then we factor this. T minus 2, t plus 1. Right? No problem. So here we have a -1, right? Another -1. And here we have 2 as a solution. So turns out the -1 and -1 are repetitive roots, extraneous solution. Only 2 is the only solution that satisfies this equation when x is equal to 1, right? Then t is equal to 2. So okay, now we've turned this into t, right? We've turned dx into, right? So all we have to do is t multiplied by dx. So 2t squared over 3. T multiplied by that one. So 2t over 3t squared. So 2 over 3t, I believe. Right? So here we're gonna okay, so this is 9 and 2t cubed. Yeah. Plus 2 over 3 log log t, absolute value, but we don't need absolute value, yeah. And also from 1 to 2. Okay. 2 goes into here, so immediately that's 8 times 16 over 9 plus 2 over 3 log 2 minus, so 1 goes minus 2 over 9 and minus 2 over log 1. Log 1 is 0, so 9 goes up. 9 minus 9 over 2, 9, so 14 over 9 plus 2 over 3 log 2.